Assalamu alaikum. Welcome to Lecture Box. I am Marina Shaukat, your teacher of Digital Logic Designs. The book we are following is Digital Fundamentals, the 11th edition, written by Thomas L. Floyd. Our today's topic is canonical form. The standard forms of Boolean expressions are called canonical forms. There are two types of canonical form. Number one, sum of products. It is also called minimum terms, represented by small m, and its value is always considered as 1. The second type is product of sums. It is also called maximum terms, and its value is always 0. The canonical form helps us to evaluate, simplify, and implement the Boolean expression in an easier way. Sum of product form. When two or more product terms are added, the resulting expression is SOP, means sum of products. For example, AB plus ABC, ABC plus CDE plus B complement C, D complement A complement B plus A complement B, C complement plus AC. In all these three examples, different product terms are added by Boolean addition. Domain of Boolean expression means the number of variables either complemented or uncomplemented involved in an expression. For example, in this expression, the number of literals are 3, A, B, C. Some literals are in their complement form and some are in simple form. But these three are called the domains. Let's have a look on the SOP form truth table. Here is the truth table I am showing you. It is the truth table of three literals x, y, z. Z is the least significant bit and x is the most significant bit. The number of combinations are 2 raised to power 3, which is equals to 8. 4 times 0, 4 times 1. Alternate 2 times 0 and 2 times 1. 0, 1, 0, 1, and it is 4 times, so the total will be 8. Now let's see how can we write its minimum terms. As I told you before, the minimum terms are always 1. So if I take its complement, it becomes 1. Its complement is also 1. Its complement is also 1. And the product of their complements will give me the value of 1, which is my first minimum term. Similarly, its complement is 1. Its complement is 1. And it will be in the simplest form. Their product will give me the second minimum term. Again, x is 0, so I will take its complement. X complement, y simple, z complement gives me the third minimum term. Similarly, let's have a look on this. X simple, y simple, z complement gives me my seventh minimum term. Let's see how can we implement an SOP expression. For an SOP expression, we will use AND OR logic, as SOP means sum of products. The product will be our first step and then we will add all the product terms. As you can see, I will use AND gates first. This will be our first step and the output of all AND gates are going to be entered into our final OR gate. So this is the sum and this is the product, sum of products. Let's practice an example. Consider the following expression: AB complement, BC complement, D and AC. These three product terms are going to be added. Let's draw their truth table by using minimum terms and implement its logic diagram. Here is the truth table. In truth table, you can see there are 4 literals A, B, C, D, 2 raised to power 4, 16 combinations. Here are 16 combinations. The first product term is AB complement. I named it as E. Second product term is BC complement D. I named it as F. The third product term is AC. I named as G. And our final result is X, which is the sum of these E, F, and G. Here you can see the all EFG answers. AB complement, AB complement, A is 0, so the answer is 0. Similarly, BC complement D, B, C complement 1, D is also 1, so B, C complement D is 1. Let's see this, AC, A is 1, C is 1, so the answer is 1. And this one is the sum of EFG. 0 plus 0 plus 0 giving me 0. 0 plus 1 plus 0 gives me 1. 1 plus 0 plus 1 gives me 1. 1, 1, 1 is giving me 1. Let's see the implementation of gates. For implementation, I will use AND gates first. Here, 3 products, so I will use 3 AND gates. The inputs of my first AND gate will be A, B complement. The other second gate with inputs B, C complement D, and my final AND gate will be with inputs A, C. The outputs of all these three gates are going to be entered into a 3-input OR gate, and X will be my final result. We can express any expression into an SOP form. For example, there are 3 expressions. Let's have a look on the second one, A plus B, which is multiplied by B plus C plus D. By multiplying every literal of first bracket with the second bracket, I will get sum of products. Product 1, 2, 3, 4, 5, 6. These all 6 products are going to be sum. Here I am giving you a problem in which you will convert this expression into an SOP form. Kindly draw its truth table and implement it through logic diagram. It is very good for your practice and I am waiting for your comments. Standard SOP. Any SOP expression can be written in the terms of its domains. As we have discussed earlier, in any expression, there are domains according to its literals. As in this expression, the domains are A, B, C, and D. But in this expression, D is missing, and in this expression, C is missing, which I can introduce it in this form. D plus D complement. If D is 1, D complement will be 0. My answer will be 1, so that's why it is missing here. Similarly, C plus C complement will always give you 1. That's why you cannot see it here because 1 gives you the same answer. By solving the bracket, I can get the expression, huge expression, in which all 4 literals can be seen. Let's try another example in which we will develop a truth table of SOP expression, which is here. So this is the truth table in which 3 literals can be seen, A, B, C, and their minimum terms can be written as this, as we have discussed earlier. According to the given data, I have to find A complement B complement C, which is here you can see. Similarly, the second expression is A B complement C complement, which you can see it here, and ABC, which is here. And in every minimum term, my answer is 1. As we have discussed earlier, in SOP expression, all minimum terms are considered as 1. We can also determine an SOP expression from the truth table. Here you can see a truth table. In this truth table, we will highlight all the ones because in SOP expression, I need 1. If in any truth table is no 1, then there will be no SOP expression. So this is my first one, my first minimum term, this one, this and this. By looking at these 4, I can write an expression. Let's see how can I write the expression through this truth table. As I have highlighted these 4 expressions, in my first highlight expression, A is 0, so it is written as A complement. B is 1, so it can be written as B. C is 1, so it is written as C. My first expression is A complement B, C. In the second one, A is 1, so I will write A. B is 0, so to make it 1, I will write B complement. C is also written as C complement. The third one, A is 1, so I will write simple A. B is 1, I will write B. C is 0, so I will write C complement. In the last one, all these 3 literals are 1, so I will write simple A, B, C. As you can see, I will write A, capital A, B, C. And then the final expression will be written as A complement BC plus AB complement C complement plus ABC complement plus ABC. So this is my final expression in the form of SOP. Thank you for watching. Kindly keep sharing the knowledge.